Catch that hope. Catch that hope. Catch that hope.
Good morning, guys. If you're on the left coast, good afternoon. If you're on the east coast, and thanks for joining us wherever you may be located. Welcome to the channel. Welcome to the stream. Day 2, KubeCon. Morning, Z-Tech. Thanks for joining us. We're back. Day 2. So it was interesting. I sent out some feedback on Twitter yesterday. Let me turn this music down a little bit. I've sent out some feedback yesterday on Twitter that actually got a little bit of traction, and several folks reached out to me privately. A lot of folks responded on Twitter about yesterday. I wanted to clarify a few things a couple minutes before we get started with day 2 here. Like, I was focused on this whole, watching the whole hour and a half yesterday, there was a lot of, here's this company with generic project A with no explanation of what the project does or what category it fits into. Sometimes you would get that loosely, but for those of us that are coming into this community of Kubernetes, cloud native, that haven't been doing it for 5 years, we don't know what all those 500 plus projects are that are in the CNCF that's growing every day. So help us. Help us know that what all of these things are. When you come up to tell me, hi, I'm from Acme, and we're doing this, we have this project or this product. Here's a NASCAR slide of all the companies using us, and we have 100 million downloads. Yeah, but what does it do? What's it for? Don't assume we all automatically know everything about your stuff. And I'm not saying turning it into an elevator pitch, but a little bit of that. You're on a grand stage here in one of the fastest up-and-coming shows worldwide. You have an opportunity. You have 60 seconds to tell us what your pitch does. If you can't tell me what your product or project does in 60 seconds or less, that's the first thing you need to fix. But it was kind of universal across the board yesterday with that first day 1 keynote. How do I know what all those different things are? So yeah, we'd love to hear what you guys thought. I thought there was some. I'm really interested in Vitesse. We're definitely going to check that out on the Friday stream a little bit more in depth. Anxious to hear what's going to come out today. I don't know if they have like each day's designated for certain things, certain categories, or what they're going to talk about on each day. This is actually my first like KubeCon that I've wholly paid attention to across the board. I've certainly heard of announcements over the past few, and then there's the regional events and things like that, but this is the first one that I said, I'm not going to be there, but I want to be able to be in a place where I can do more stuff. So I'm here watching the keynote with all of you here on the stream, but at the same time, I want to do some more. I want to read all the articles and follow Twitter more in depth. What's all the news? I want to look at some of the projects on GitHub. We may do a little bit of that today after the keynote, but I definitely want to save some of that for Friday. I'm making notes of things that we want to go back over in more detail, and we'll do a lot of that on the big Friday afternoon stream. So make sure you guys, before we get started here, thanks for coming. Welcome to the stream. Welcome to the channel. Make sure you hit that follow button, the little heart up top. Make sure you get notified whenever we go live. We stream every Friday at noon Eastern. We're doing cloud builds. We watch watch-alongs with some of the videos, whether it's Tech Field Day or some of the other stuff that might be out there. We've got a lot of trade show content to cover. We did everything for Ignite the same way we're doing this. Oh, here we go. Thanks for joining, guys. Let's see how it goes. Oh, he's back.
Southern California.
Audio up.
Play the lottery today. I think you might have a winner. All right, so
as a former LA resident, I can
continuing with
vouch
our
for that.
theme of how our ecosystem has matured. Yesterday we focused on how our projects are becoming more advanced, but today we're going to dive into how our use cases are growing more advanced. So the first talk that we're going to have today is Vicky Chung. Vicky is an engineering manager at Lyft and my fellow co-chair here at KubeCon. Last night, she gave us an update on Kubernetes, and today she'll discuss how everything was working before Kubernetes. Please welcome Vicky to the stage.
Everything is awesome. Everything is cool when you're part of the team. Everything is awesome when we're living our dream. 3, 2, 1, go.
Hey, good morning. Please bear with my voice because I have a cold and have completely lost it. So everything was working before Kubernetes, but not me, I guess. Okay, so I'm Vicky. I work at Lyft. I've been running Kubernetes for different types of workloads in production for about 4 years, which I think makes me think I'm kind of an early adopter. And I've heard the sentiment of everything worked before Kubernetes quite a bit over the 4 years. I think it's a fair statement, but I'd like to offer a little bit of insight into how we as an industry has evolved over time and why I think things are actually better. So to dive into answering this question, I think we have to first ask what was before, what was working. I think it was a simpler time. And I'll go through some examples from my personal experience that I think seem to be a fairly common progression. Okay, so maybe you have something like this. This is like almost how every company I've worked at sort of evolved. So you start with a single monolithic app as you prototype a new idea and you sort of prove your idea out. And then hopefully it's like working, so you start hiring engineers. And you start having teams. And then your app keeps growing. So you break up the app and so that you can have some sort of separation of concerns. And then you just sort of continue growing organically that way until you're like, oh God, what have I done? You start running into limitations on actually many things. You start running into limitations on how do you even run the stack on your laptop anymore? Like, how do I even develop locally? Other limitations might be with your cloud provider. You might have trouble loading your cloud provider's web console because you just have too many things. Here's another example from maybe machine learning. So maybe you start doing machine learning experiments. You have one researcher running training on their laptop, and everything's fine. And then you start training bigger and bigger models. So now you're like, OK, that doesn't fit on my laptop anymore. So let me train on the beefy box somewhere else, maybe in a colo, maybe on a cloud. And then hopefully things are going well, so you, again, start hiring more and more people onto your team. So now you have a fleet of these beefy boxes. And then you're like, oh, what even is running anymore? I don't know how many people have worked with machine learning scientists who have like literally lost their experiment somewhere because they forgot where they were running it. So I think in this model, infrastructure teams are often the bottleneck because you have to figure out how to manage and version control this fleet of beefy boxes. And you have to manage how to upgrade them, how to do security audits. And you also have to make sure that you're actually using your resources effectively. And maybe it's because of cost savings or whatnot. And the team that manages this environment might be your same infrastructure team or maybe a different team entirely. So meanwhile, hopefully, your business is booming. So you have all these new requirements. Your team keeps growing. You have all these data scientists and machine learning researchers and more. And meanwhile, you have to move fast and also do all these things like multi-region, sprinkle some GPUs into your fleet, maybe do multi-cloud. So you have to think about how to empower your engineers to be productive in this environment while like never going down. You have to be online globally all the time. We don't really see maintenance windows anymore. Like, this was the thing when I was little. But like, every time I see a maintenance windows now, I'm like, what are they doing? So, okay, so where do we go from here? There are all these requirements for your infrastructure team. You have to keep up with all these business needs. How do you scale your team without being the bottleneck or the gatekeeper? Things were working before. They worked well enough that we got here. How do we keep them working? So we turned to the community, and step by step, we started putting the pieces together. So we are where we are because we turned to open source and started building agreements on what abstractions we wanted. Kind of like how we started converging on Linux as the base OS. We agreed on containers for empowering developers and moving fast, and we agreed on Kubernetes for orchestrating these containers at scale. By leveraging this huge community effort, infrastructure teams can provide flexible building blocks for their end users. And clearly that resonated with a lot of people because, I mean, we're all here. And this is the graph that always gets cited for how the interest in Kubernetes just keeps growing.
Except for that one weird spike in 2018.
So, are we happy? Is everything awesome now? Well, I think people make fun of how much YAML they write. I think partially it's a testament to how straightforward and extensible the Kubernetes API is, and more importantly, how user-centric it is. For non-infrastructure engineers, they can do a lot by just manipulating these YAML files. So we've sort of made a lot of progress to expose this higher level abstraction and to support all these use cases. But it's not all awesome yet. It's not rainbows and unicorns yet. So we still have some ways to go. We took on this super ambitious task of empowering our businesses and developers to meet all their needs. And Kubernetes gives us a path to achieving all of that and scale with the complexity. But the complexity didn't really fully go away. We are still supporting all these things. For the infrastructure team, Kubernetes can feel complex because in order to support all this flexibility, our infrastructure teams are taking on new responsibilities. For the end user, while their deployment to production becomes more flexible, they need to relearn aspects of development in this new world. So I want to talk through some of the specific challenges that I've encountered in my experience introducing Kubernetes to engineers, and go over what the community is doing to address them, and where do we go from here. Okay, so one question I always get is, now that we've built and provided this platform where we empower application developers to deploy whatever they want to the cluster, how do we control what's running? How do we prevent one user from taking down our entire cluster? So while there are controls that you can implement today already, if you're an enterprise or maybe you're a bank, you might want finer grained controls over what runs in your cluster. So one path forward that the community is investing heavily in is open policy agents. This is an example of how a simple snippet like this can be used to restrict what images can be run by the containers on your cluster. And there have been a number of talks at this conference digging deep into OPA, so we can show the interest from the community in this direction. Another question I hear often is simply, how do I develop? Like, now that we've moved into this world of immutable containers, running on the cloud. How am I supposed to develop my application? How do I get to a workflow where I can use my debugger or iterate as fast as I used to, just running Python on my laptop? And there are other people who have asked this very same question, and there are a lot of answers out there. There isn't a clear one winner, but these are just some examples of open source projects that are tackling this very problem. There's so many awesome options. They all take a slightly different approach in solving this problem. So your pick might be different depending on the workflow that your organization is used to. I want to give a shout out to the application development track where some of these projects are getting covered. So if you're interested, there are some talks today about that. Related to being in an immutable world, this is by far the most common question I get, which is how do I debug? Do I have to just keep adding print statements and rebuilding my images and deploying them and then looking at the print statements and then just keep going until I figure out what's wrong, which is what I think a lot of people do. It doesn't have to be that way. It doesn't have to be that painful. And in particular, I'm very excited about this new feature in 1.16, which I covered yesterday. It allows users to attach a debug container to a running pod, and you can share its network namespace. You can also share its process namespace. This opens up a whole new world of possibilities for how we think about debugging in this world. So for example, you could have a running pod that's maybe crashing, or maybe it's already running, but it's not doing what you want. Instead of adding print statements or redeploying the pod until you get it right, you could just attach another container with all the debugging tools you need to this running pod and just use other tools that are not in your images. So I think one useful example for this is a lot of times people have maybe misconfigured their credentials or maybe misconfigured their network. You can use this to dig into what the pod is seeing. And overall, if I look at the theme of the common challenges that we just went over, I think that we've evolved to a place where we're iterating on user experience. We started with this huge problem space. Kubernetes provided the foundation for orchestrating containers and the building blocks to power our workloads. Now that the building blocks are in place, we can focus on building higher level, or we can focus on working on higher level problems to simplify and improve the user experience. And I think that, again, everything worked before Kubernetes, but it was unclear that it was going to keep working as well as they did, given all the new requirements that are asked of us. And I think that, thanks to the community and everyone here, we're getting there with Kubernetes. Thank you.
Everything is awesome. Everything is cool when you're part of the team. Everything is awesome when we're living our dream.
All right. So our next presenter is Vijay Pandey. Vijay
So
Pandey
much I wanna
is
say,
a Vice
but-
President and CTO of Cisco's Cloud Platform and Solutions Group. Today, he will demonstrate how easy it is becoming for developers to consume networking via network service mesh. Please welcome Vijay Pandey.
Whoever's running the feed.
Thank you, Brian. And good morning, San Diego, even though it feels like Seattle outside. So back in Barcelona, I talked about the need for networking to evolve for a cloud-native world. Today, I'm going to talk about how that evolution is critical, and it's already happening by looking at a real-world use case. But before I do that, I have a question for the audience. Are you a real programmer? Now, before you raise your hand, let me point out that the comic strip that you see behind me is a mashup of 2 comic strips from XKCD and 1 from User-Friendly. And in that, you see a programmer sitting at their desk, and a person approaches them and says, Nano? Real programmers use Emacs. And this begins a parade of people who say, no, real programmers use Vim or Cat or Ed. But the clincher is when somebody walks up to them and says, you guys are all wimps. Real programmers use magnets to edit the inodes directly on disk. That is one viewpoint. Another viewpoint, it comes from Leslie Lamport, who got his Turing Award in the field of distributed computing. So he knows a thing or two about distributed computing. And he says, coding should be the easiest part of programming. And if you're having trouble coding, you're doing something wrong.
That's a good point.
Now, what does this have to do with networking? For one, networks are a key component of any distributed system. So let's take a look at the real-world scenario and see how networks are programmed today in a cloud-native environment. In this picture up here, we have a use case where there are 4 databases, 3 running on public clouds, 1 on-prem, and they simply want to communicate with each other securely to be able to either shard and or replicate. How would you solve this today in a cloud-native world? By the way, congratulations to Vitesse on graduating and becoming a graduated project. So one way to program that network is to use magnets. So you start with the technical complexity of dealing with ever-changing pod IPs, of dealing with different routes for different clouds, firewall VPN complexity, different configs and compliance needs for the different cloud vendors, and that's just technical complexity. Then you run into organizational complexity, where you have devs and DevOps and NetOps and SecOps and colo providers and cloud providers, and you need to talk to all of them. And each one of those labels is not a single person, it's a team. So meetings and tickets and meetings and tickets, magnets. Finally, there's process complexity. Is there a process? Is it stable? Who is accountable? More meetings, more tickets. A developer's best friend. Not. And all of this is happening because the application architecture is changing in a cloud-native environment, and therefore the organizational architecture and the operational architectures are changing. And so you cannot use the concepts for physical and virtual networking, which were aggregate statistical networking concepts, like switches, routers, vSwitches, vRouters, BGP, to solve application-level problems. We need to simplify connectivity paradigms for application development. And this is where enter network service mesh. So we are a sandbox project in CNCF. We got our sandbox status back in April, around the time of KubeCon Barcelona. Roughly 40 contributors and counting, and extreme interest from financials, enterprises, and SPs. As you can imagine, nobody wants to deal with magnets.
But what does it do?
And we had our first ever day 0 event, and it was 180% over capacity. So as a community, we are extremely excited about that. So how do you solve that problem that I just described using NSM?
Here we go.
Very simply, all you do is extend your CRD with a line that says, I want to belong to the DB replication NSM domain. And then NSM magically takes care of securely connecting all of those database pods and ensuring that only those database pods talk to each other. Now, behind the covers, things are a little bit more complicated, but still pretty simple, where you have a network service endpoint running in every cluster that takes care of the data plane between these database pods, wherever they happen to be. And then there is an NSM registry that figures out the discovery process of the remote endpoint, again, wherever they happen to be. And all of this is done for the developer without them knowing anything about IPs, routes, subnets, or any special CRI.
Yeah, but somebody has to set all that up.
Now, if you want to look at a demo of this, this exact same demo is running at the Cisco booth, so please come by, take a look. There are demos on application security and observability. You can talk to the NSM community. Reach out to us, please. And then if you visit our booth, you will get stickers with, say, magnets or NSM. Take your pick.
I mean, look, he wasn't the worst one if we include everything from yesterday. I mean, at least he went over NSM to an extent. Like, come on, guys. It's the same thing we had yesterday.
So VJoy left this up here, so I get to use it. So if it was 10 years ago, what would I be doing right now? Distributed computing. This is Kubernetes Alpha 1. All right, so our next presenters are Tim Hocken and Cal Hendiak. Tim is a principal software engineer at Google, where he works on Kubernetes and Google Container Engine. Cal is a software engineer at Azure. Today, they will share the journey of how IPv4 and IPv6 dual stack Kubernetes has progressed over the years, and how the community has banded together to land such a massive change that touches almost every part of Kubernetes. Please welcome Tim Hocken and Cal Hendiak.
Come on, boys. Pick it up. We need some energy in this. It wasn't the hottest start for day 2.
All right. Thank you, Brian. Hello, KubeCon.
Hello, everybody. My name is Tim, and this is my friend Kyle. We just pulled a fast one on you. We are not going to talk about IPv6 or dual stack, hardly at all.
Good.
We chose the most boring, most pedestrian topic and title that we could possibly come up with, just so that we could get up on the stage. Now we're going to talk about whatever we want.
Bravo. Now we're talking.
Those of you who know me, I've been around the project for a very long time. One of the roles that I have been privileged to play through this project is being part of the Bootstrap steering committee. Our job was to look at what our community had been doing and to think about what made it successful and to set up the overarching governance that was going to carry that forward and make sure that the project continued to be successful. We met and we agonized for days over how do we capture those principles? What are the things that are really important about this community? Because there's something special about this community, and how do we capture that and keep it going? So we had lots of ideas there, but there was one principle that I think really captured it more than any other. And that principle is this: project over company. The project is more important than any one company. When we wrote those original steering docs, Kubernetes was already kind of a big project. Now, it is significantly bigger than that. Now, we love to get up here and talk about our community, but what does that really mean? Kubernetes community is made up of people. People from all walks of life, from all over the world, from every time zone, and importantly, from many, many companies. Sometimes, often, those companies are in direct competition with each other. But Kubernetes is so much bigger and so much more than any one of these companies could have done.
Truth.
We're working together towards a common goal. Co-opetition, without it, Kubernetes would not be but a fraction of what it is today. So, since I've been around for a while,
We'd still all be doing VMs,
seat
which
to
most
all
people
of this
still are.
And what's going on. This is really the heart of what we think of as our community. Today, we'd like to tell you a little story about how this principle has allowed us to add a complicated new feature to Kubernetes, and how it would absolutely not have been possible without our community.
CSI?
So, like any software project, we've added capabilities and features over time. We've accumulated and accreted, and those things are in direct response to user demand, right? We get a lot of pull requests, a lot of feature issue filed that are asking us to do things. And these things are contributed by lots of people with varying skill sets and varying sets of expertise. Now, anybody who's played with Kubernetes can understand that networking can be tricky, right? And pretty much everybody here is probably familiar with TCP/IP, right?
Yep.
Those dotted quads that you see, 10 dot whatever, 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 those are actually IPv4, right? And when most of us think of TCP/IP, we think of IPv4. Now, a little confession here. I am not actually a networking expert. Everything I know about networking, I've learned through Kubernetes. But early on, somebody had to do it. I drew the short straw, so that was me. So what we're familiar with is IPv4, but there's this whole other thing that we ignored, IPv6.
Everything
Like
I've
many
learned about
projects
networking,
in
I've
this
learned
space,
through
we have
Kubernetes.
quietly
Come back to
accumulated
that one.
IPv4 isms, and that's not good. Our code base now is really locked into IPv4. So a couple of years ago, a handful of motivated people stepped up and decided we're going to fix this. And a working group was formed. This is how we do things in our community. And these folks did a ton of hard, grungy work, and they exercised most of the IPv4 isms from our code base. And they made Kubernetes compatible with IPv6. Hurrah, IPv6. We're done, right? So first of all, special thank you to all those people who stepped up and did that work. We're done.
A bigger problem remained. The reality is users wanted to use IPv6 because they wanted to integrate with IoT compute-like computing stacks. But then these applications are not going to be deployed in vacuum, right? They need to integrate with existing IPv4 services, cloud services, endpoints, and apps. OJ just wanted to use IPv6 because they ran out of addresses. Just recently, the EU handed out their last EU IPv4 block. The EU has no more IPv4 addresses today.
Whoa.
So when you think about it, users wanted to use IPv4 and IPv6, and we call that dual stack. Easy problem, right? We just run IPv6 and we're done. So we started this journey, trying to do the work, and we start with the APIs. Like any Kubernetes journey begins, we picked up the first API object, pod. Then we looked at it, and oops, it has one IP. But we need two, right? One for every family. We did the same for Node, and then Node has one CIDR. Oops, we need more. Services, endpoints, you get the picture. What we just realized is we've made a bad assumption. We've made an assumption that everything Kubernetes will always be single IP. Then, can you switch? All right. So, as we looked at that, the assumption that we've made actually not only to the code base, but also to the ecosystem. Everything Kubernetes was just speaking single IP. From the bootstrap tools to the load balancers to the CNI, everything is single IP. It's everywhere. That challenge does not deter us as a community. As a matter of fact, people get excited by challenges like that. With that spirit, a group of us started the work on dual stack, probably late 2017, October, November timeframe. By June 2018, they had a Kubernetes enhancement proposal, a KEP, as we call it. With everything that we wanted to change in Kubernetes, the KEP was just enormous, right? The team that picked that KEP detailed every single change, every impact, everything we needed to work on to bring dual stack. That KEP itself is an example of how to write KEP for Kubernetes, by the way. But then things happened, team couldn't carry it forward, and dual stack efforts stalled. Like everything Kubernetes, our ethos is ownership. Without owners, things doesn't exactly move forward. As Tim said earlier, the requirement, user requirements is our primary drive. The effort has stalled, but the requirement didn't go away. By 2019, it has become even more pressing. In our never-ending relay race, the baton was handed over to us. Myself as on the implementation side, and Tim on the reviewer side, basically to make sure that I don't run too fast with scissors. With a new team in place, our first order of business was to get that KEP, the uncompleted KEP, over the finish line. And we did. The second order of business was to break this enormous effort into phases. We chose to go with 3 phases, each mapped roughly to a Kubernetes release. First phase, we wanted to do the egress. We wanted to allow pods to do dual stack. Second phase, we wanted to do ingress. We wanted to allow traffic and clusters to receive dual stack traffic on both IPv6 and 4. And then the last phase is to bring this all together in our ecosystem, help load balancers, CNIs, bootstrap tools into their adoption journey. These changes are not exactly easy, but also we wanted to execute them the Kubernetes way. Having the feature is good, but it's not good enough. We wanted to make it easy to light up these features on your existing clusters. Not just that, we wanted to make sure that these changes are backward and forward compatible, meaning you don't have to exactly break your clusters that you're upgrading, hopefully.
So now we have a problem. We have a new API problem that Kubernetes has never had before. How do we take a singular field and turn it into a plural field and stay compatible with all of the clients that are out there? Because I think we have a few clients out in the wild. How do we change the assumption of a single IP to multiple IPs across multiple resources, pods, nodes, services, endpoints? This was going to be a bit of a challenge. So we took it apart. All of the obvious solutions were unpleasant for various reasons. We really didn't want to rev the entire Kubernetes API to version 2 just for this. And even if we did, we still have to have a compatibility story anyway. Anybody who knows Kubernetes in our community knows we love a good debate. So we got into it. API reviewers and a bunch of other senior folks from the project who had good context came, and we talked about this at length for literally months. We argued about this. So again, I want to put out a big thank you to all of the API reviewers and the folks who participated in this debate. We came up with a model that mostly does what people would expect most of the time. I feel pretty good about that. So I don't want to bore you with the details of the API. I'm happy to talk about it later if you want. We won't go into those details now. But now that we know how to enact those changes, Cal started hacking. Let me tell you, this man is prolific. The resulting pull request was, I think GitHub's official term is kind of large. Just the phase 1, just egress, was over 5,500 lines of code. And it changed 2 core API types, pod and node. We consider those to be sort of high-risk changes. So we had to think really hard about how to do those changes, make sure that they were correct and they were complete. And we don't, like you said, we don't really want to break people's clusters if I can avoid it. These are the sorts of PRs that reviewers bring pitchforks to. We also had to change a bunch of core controllers. And I say we, but I really mean Cal. I just stood back and watched. So we changed the endpoints controller, the node IPAM controller, the route controller. And this is all just phase 1, remember? So now we're approaching the 115 code freeze date. We can see it in our headlights. We're coming off of KubeCon EU. We're just coming out of a long weekend. We really want to get this thing into the release. But truthfully, time and review bandwidth are super limited. Everybody who sent me a pull request towards the end of a code freeze window understands what that means. We realized that this PR needed to be sharded out. We needed help. This was more than a one-person effort. So we lit up the bat signal on SIG Network.
What happened after that is we were floored by the reaction. In a typical bad signal situation, you would expect 1, 2, 3 people to step up. No, not in this community. 18 people stepped up. 18 people stepped up to help. We split the review into multiple pieces. I personally remember who can cover this piece on the SEC call. A lot of people were saying, I can do that. We went through the daily crunch of review, fix, commit, as a collective, as a community. Ultimately, we made the decision to set out V115 release code, just to give us more time to review and give us more time to test this and just leave the change on our test grid. We missed our mark, but that's fine. The memory of that week is one of the memories that we as a community will cherish for a very long time to come. Admittedly, we were beaten. I was. I know I was. A lot of effort were put into this change. A lot of effort 2 years back were put to bring that change forward.
Come on, guys.
We
Energy.
just fell a little short, but we were not defeated. We were back at it again the next release, V116. This time, we wanted
This has
to go
to be
bigger.
one of the
We wanted
slowest
to do egress
snoozed
and
fest
ingress.
keynotes I think I've ever watched. And we're
Not
20
because
minutes
this
in?
is how mad we are in Sig
30
Network.
minutes in?
We do.
Holy, we got to pick it up, guys.
But by then, it was clear. We were supported by a very strong community. All right, let's do this again. Going back to the drawing board, another API discussions, you know, the one that we lovingly yell at each other for a while until we come to an agreement. This time, we wanted to change kubeproxy, API server, load balancing. You know, it's just another small change. And we made that release. As of V116, Kubernetes supports dual stack. This is your cue to clap, by the way.
Congratulations. That's no small feat, for sure, to be clear.
Our journey is not over, never is. One thing for sure, the sky is clearer ahead. Kubernetes today supports dual stack on both egress and ingress paths. We are well underway on our phase 3. I see friendly faces in the community helping. We have dual stack bootstrap, we have dual stack external load balancer, CNIs. You get the picture by now. We are already thinking about what's next for Kubernetes networking. We want to go further. We want to enable multi-IP pods, be it dual stack or not. That will enable applications to do front-end, back-end classic networking scenario.
They turned the
Anybody who's
volume
old enough
down.
like me will remember that. The other thing we also wanted is to make it easy to run networking virtual appliance on Kubernetes. We are super excited about the possibilities. We already unlocked these possibilities, so we just need to do the work. More importantly, personally, and all of us, I think, we are super comfortable thinking big and bigger because we know by now the community will come and deliver against this future.
So wrapping up, I feel like I should emphasize a few things. Almost none of us who pulled this off knew each other before this. This is, I think, the first time Cal and I have actually met. If it was, again, it was at a KubeCon in passing. And, you know, I don't even like this guy. I'm kind of a Star Wars fan, and I hear he likes the other thing. Almost none of us work for the same companies. Many of us don't work in the same countries, in the same time zones. But when we all pulled together, something really exciting and awesome, and I really mean awesome in sort of a biblical sense, happened. This is what project over company means to me. This is why Kubernetes is what it is. So this talk is our little way of saying
Thank you.
thank you.
Yeah, I mean, huge shout out to the community that pulled off that work. Putting 20 people together and doing daily scrums like that over and over and over, day after day after day after day, is no small feat.
So before introducing our next speaker, I wanted to actually think about what the other thing was. Not growing up in this culture. Is the other thing G.I. Joe? Is it Care Bears? We'll talk about this, Tim, so I can figure that out. But on to our next talk. Our next presenter is Ray Wang. Ray is a group product manager at Google and leads the product team for GCP identity, config, and policy management. Today, she will share stories on how Kubernetes and open source tools are built, Kubernetes and open source tools built on top of it are transforming the impossible into possible. Please welcome Ray Wang.
Baby, you're a firework. Come and show 'em why your work. Make 'em go.
Hello, San Diego. Do you all know what that song was? Right, it's called Firework, and it's very befitting because we're going to start with a birthday celebration.
Oh.
10 years ago, in
we
November
were gonna talk about
2009,
Firecracker.
the new programming language Go was first announced. Its simplicity and ease of use quickly gathered adoption. Go became the programming language that Kubernetes was created upon, along with countless other cloud-native projects. So today, let's wish Go and its community a happy birthday. Okay, now let's talk about Kubernetes. I want to start with a story that perfectly illustrates the power of Kubernetes to transform what was once impossible into something available to everyone. Gaming at a global scale represents many challenges from development to deployment. In the world before Kubernetes, game developers typically had to create and maintain their own bespoke infrastructure platform, spreading across thousands of VMs in data centers around the world. Then on game launch days, burstable compute in hybrid deployments was extremely difficult. You had to massively over-provision. And then Agonis, created on Kubernetes, changed it all. Now developers can actually focus on creating features instead of building platforms, massively reducing the time to market of the new games that you and I all enjoy playing. Rapid iteration, the decoupling of operations from development, and true hybrid cloud deployments are now a reality. And amazingly, the MVP of this open platform built on top of another open platform only took 3 months to create. Now, these wouldn't have been possible without community. So I want to thank all of you for the tens of thousands of contributors and hundreds of thousands of commits. You have even created a new job sector around Kubernetes expertise. Congratulations. Now let's look ahead to 2020. It's around the corner. The best way to predict the future is by learning from our most forward-leaning Kubernetes customers. Here are a number of trends that we have observed from their successes. Kubernetes as the core of hybrid and multi-cloud architecture, and using Kubernetes to scale exponentially and efficiently, and Kubernetes resource model extending beyond clusters. Let's understand them better from real customer stories. Equinix is in the business of modernizing internet connections and data centers. They understand that business needs and infrastructure choices can change over time and need a strategy to minimize the churn. For that, they have embraced Kubernetes to create a best-in-class technology stack for hybrid and multi-cloud environments. With this stack, Equinix can now adapt to all these different changes without having to rewrite the applications or management tools. As more and more companies adopt a hybrid cloud strategy, we expect Kubernetes to become the core of the multi-platform architecture throughout the industry. And that is our first prediction. Now, who loves digital music and Spotify, right? To serve more than 200 million users' favorite music, Spotify has a containers and microservices-based backend. The recent migration from VMs to containers has significantly increased their engineering productivity and infrastructure efficiency. Kubernetes has stood up to the rapid growth of Spotify users, serving more than 10 million requests per second. And has also enabled Spotify's central platform team to support an increasing number of DevOps teams and microservices through a higher level of automation. So that's our second prediction, using Kubernetes to scale exponentially and efficiently. And now let's talk about Shopify. Shopify is an e-commerce platform that supports more than 1 million businesses around the world. They saw the power of Kubernetes resource model and fell in love with it. Single source of truth, declarative configs, and continuous remediation are the ideal way for managing configurations in Kubernetes and beyond. So Shopify created CRDs for all of the dependencies, from databases to storage and so on, and now uses KRM as the consistent model for managing all of their resources and services. So that's our third prediction, the power of Kubernetes extending beyond clusters. KRM and the toolings around it are becoming a state-of-the-art manifestation of config as code across all resource types. And of course, these are just a few stories from the many companies that are succeeding in their modernization journey using Kubernetes. This open source community that you all are part of is really changing how services are created and operated around the world. So with Kubernetes, the impossible becomes possible, and the future is here today. Thank you.
I'm having trouble today, guys. I gotta be honest. This is tough.
Our next presenter is Heather Kirksey. Heather is Vice President of Community and Ecosystem Development at Linux Foundation. Today, she will bring up Azar Sahid and Fu Chao, and they will discuss a cloud-native approach to developing an end-to-end 5G network, proof of concept built on open source infrastructure, and then they will demonstrate with a live prototype running in labs around the world using Kubernetes and other open source technologies to deliver a fully containerized 5G network. Please welcome Heather Kirksey.
All right, energy, fun. Let's go.
Good morning, San Diego.
Morning.
How are y'all doing this morning?
Fantastic.
Y'all having a good KubeCon? Come
Not
on,
yet.
great
Pick it up.
KubeCon. So I have
go.
to say, this is the first time I have ever come to stage accompanied by a rack of servers and a Faraday cage. But this is going to be an exciting demo that we're doing here today. So I have spent the majority of my 21-year career in the telecommunications industry. And that has been not only because of its rich history of innovation, including things like the transistor, the semiconductor, the discovery of cosmic background radiation, the creation of Unix, the creation of the C programming language, but also because fundamentally network is the key and foundation of all of the connected applications and services that we use today. No network, no obsessively checking your Facebook 20 times a day. No network, no Netflix and chill. So the network is fundamental, and working on the network is a really extraordinary and amazing thing to be doing with one's career. So within telecommunications, we have been on what we call an NFV journey for quite a while. Back in the day, telecom networks were deployed using custom-built sort of devices. These were custom operating system, custom silicon. They were vertically integrated, purpose-built, generally did only one or two sort of functions in the network. Over time, we began sort of moving towards more and more kind of general purpose compute, general purpose operating system. And then in about 2014, a white paper was published by a standards organization called ETSI, talking about something called NFV, or Network Functions Virtualization. Y'all call it cloud. One thing to know about telecom industry is if we can turn something into an acronym, we will do so. So NFV had the idea that these network functions, all these devices that we deploy around in places like central offices, telephone poles, and radio towers could actually be deployed as cloud applications. And so we started moving that way using VMs and OpenStack, and then started thinking about how we might do that in a cloud-native fashion. So as we think about doing cloud-native, we had this idea, let's actually build a prototype 5G network that is completely cloud-native, built with open source components, and then let's demo it live in front of 12,000 of our closest friends. This may have been a harebrained scheme. So who is this we that I am talking about? We are LF Networking. Like CNCF, we are an umbrella foundation of open source projects underneath the auspices of the Linux Foundation. We work on things from high-speed data planes to service orchestration and integration with the telecom back office, systems integration, automated testing, CI/CD for telecom networks, compliance verification, software-defined networking, big data applications for telecom, open source network operating systems for switches, and the ability to do large-scale network monitoring. Our operator members represent 70% of the global subscriber base. And so our very first project in the networking space was Open Daylight, and I think that it started about 7 years ago. So in telecom, we've actually been on this open source journey for a while. So we also work with other open source and standardization organizations. We work with a lot more than are on this slide, but these are the ones most relevant to what we're showing you today. Obviously, CNCF, this is a cloud-native demo, so we work with them. The Open Air interface is an open source project that has been working on radio and mobile technologies in an open source fashion for several years. The ORAN Alliance is a new project in the Linux Foundation. It is both a standardization effort as well as an open source project, also working on radio and 5G mobile networking. And then the GSMA is the largest association of mobile operators. They put on Mobile World Congress every year, if you're familiar with that event. And we actually created a partnership with them earlier this year, where between OPNFV and GSMA, we have created a joint task force called CNTT, another acronym. And we're working on defining reference architectures for cloud deployments and cloud infrastructure in service providers. So, what is 5G, besides a buzzword that is in every single article you read in telecom these days? Simply put, it is the next generation of cellular technology. We have gone through multiple generations. When I started using cell phones, it was actually probably 2G. And then we had 3G. Most folks are on LTE right now. 5G is the next iteration. It is characterized by extremely high bandwidth, extremely low latency, extremely high density of devices that can connect. What that means is that there is a great deal of scale needed to do this. To have the high bandwidth and the low latency, we need to move the radio out a lot closer to the end devices. And so that presents some challenges. But essentially, this is going to be the network that is available to mobile operators in the future. We're expected to have 50 5G commercial networks across 27 countries, and the global market is expected to reach just under 700 billion by the year 2026. So it is massive in terms of scale and massive in terms of economic impact. But don't take my word for it. Let's hear from the largest mobile operator on the planet, China Mobile. So I'd like to invite to stage Fu Chao, who's the technical lead at China Mobile. Fu Chao, come on up.
Thank you, Heather. Thank you. So good morning. I'm Fu Chao from China Mobile. So I'm here to bring the use case of 5G in China Mobile. Talking about 5G, we actually begin our commercial service of 5G in 50 cities in October the 31st in China. So from our perspective, what see 5G is not only just the next generation of telecom technology, but we see that as somehow the innovation and transformation actually for all the telco technologies. First, we are expecting it, of course, as a basic infrastructure to support services, not only telco services, but also edge computing services and other third-party services. And secondly, we're also thinking that 5G could enable other fancy technologies, including big data, edge computing, artificial intelligence, because of the benefits it could bring with low latency and high bandwidth. And thirdly is about 5G will be a healthy ecosystem, which will provide the sustainable growth of the creation of new 5G applications. With all of these, we're thinking that 5G could possibly bring innovation and transformation for other industries, including healthcare, education, and smart cities, for example. So how does the 5G network actually look like in China Mobile? We're actually working on that like a core to edge structure, where we have most of the control plane services located in the core. We are now actually building 8 core clouds across the country in 8 different provinces in China. And then we will bring up hundreds of edge clouds across the country distributed with all those user plane services. We have 5 expectations of our 5G cloud. First is about the resource. We're expecting that the resource could be globally scheduled so that we could actually move our services across the cloud. And second is about the capacity. Second is about the capacity, which means that we will expect the capacity could move, scale in and scale out with the requirements from the services, actually. And third is about the structure. We're expecting that the structure of the 5G cloud could flexibly tuned. For example, when you move to the core, the structure could be a little bit complicated, taking consideration of the redundancy, shared storage, for example. But when you go to edge, you have to be better trimmed the structure so that it could fit into the limited space and power of the edge spot. The fourth one is about the deployment of the services, where we are expecting to pull up new services within minutes, or rather than within days, weeks, or even months. And last thing is about platform as service. We expect that to be fully open and could share with the services with common APIs and capabilities. So while we're actually building this 5G cloud, there are three major challenges we are actually now facing. First is about the infrastructure. We say that it's still insufficiently decoupled. Comparing with some of the bulky hardware in the past, we're still bonded with some software silos from a single vendors. And that could really give us some trouble when we actually want to share the global resources of the cloud. So we're expecting that infrastructure could evolve from the VNF bounded to actually white box, with the APIs and capability defined by some community-driven efforts. Second is about service, which is still insufficient service-based architecture because we're still lacking of common services at the platform level. So instead of building some of the services in just a single VNFs, we're expecting to break it up to cloud-native components. And last one is about the operation capability. It's funny to say, actually, but operation is actually now a quite big obstacle for telco operators. Comparing with the increase of complexity of the network, we're still lacking of sufficient ways to do the operation. So now we are thinking that we could evolve the operation to not only software-defined, but also intelligent-defined, utilizing the technology, including automation and artificial intelligence. So with that, I will get back to Heather to explain more about the demo and how we actually address these expectations and major challenges.
Thank you, Fuchao.
Thank you.
So as Fuchao was sort of speaking toward at the end of her part of the presentation, there are some challenges that operators are dealing with as they're considering 5G. So the question is, can cloud native technologies help address some of those issues? And our presumption is yes. Sort of talking about, I talked about the massive scale that we need to do, and certainly Kubernetes and cloud native is really great at scaling. It's very great at flexibility as we want to do more interesting and sophisticated things with our network and roll out really interesting network services. The performance we think is great, and sort of utilizing sort of we've been doing some benchmarking of performance with the CNF testbed and see a great deal of performance improvement, as well as sort of the resilience. If you think about the network, this is what the 911 system depends on. This is what goes into communication amongst flight towers. The network really impacts sometimes physical health and safety. So we really have strong requirements for uptime and resilience. And fundamentally, having a common infrastructure for applications and the network, utilizing some of the lifecycle management makes things a lot easier. And then the last point is that we really want to be able to work in partnership with the large ecosystem of developers that are building cloud-native applications. It gives us a lot more access to a lot more technical folks who are going to come up with the really interesting, innovative services that are going to go onto this next generation network. And so with that, I would like to actually start digging into the details of the demo. So I would like to invite Azhar Saeed, Chief Architect at Red Hat, who is one of the developers who has been helping us build this demo. Azhar.
Thank you, Heather. Good morning, San Diego. So as Heather stated, we actually took on a very ambitious project in order to build everything in containers and build an entire 5G network, from the radio to the core components. And we started off this project with partnership from different vendors as well as open source communities. And first it was OAI who signed up and said, okay, let's build this as a live network in France. So that's what you see as a Eurocom facility in Sophia Antipolis in France, where they actually have live radio deployment and a core deployment. Then we built a POP in Montreal with the help of one of our partners, Lenovo, to actually build the entire infrastructure and run a core over there. And with that, we said, well, how interesting would it be if we were to actually bring an entire POP right on the stage here with us that is remotely connected to the core in Montreal. So that's what you see here at the back with these noisy fans is the full edge POP with, some servers that do edge compute, that do the radio capability with a Faraday cage that was custom built just for this particular demo, and a 5G radio in there. So I'll walk you through those in a moment. Let's go look a little bit deeper into what each one of these setups are. So the first one is the San Diego POP. And what you see in the San Diego POP is essentially a 5G phone that's connected to two different radios, the LTE radio as well as the 5G radio. And then you have a piece of software that's running on a whole bunch of servers that you see in that POP. That software is essentially the radio software, CU and DU. That software is also a firewall that's all running in containers. It's also an SD-WAN gateway. The firewall is from our partner A10, and the SD-WAN gateway is from our partner Turnium. And we have actually an interesting software-defined fabric that's also part of this same setup. And I'll just walk you through very quickly in a moment. Let's now go to Montreal, what the setup in Montreal is. Well, in Montreal, we have a full data center setup. It's, again, Lenovo servers, the ThinkSystems SR630 and 650, as well as a number of container network functions from A10, from Turnium, from Altran, from Kaloom, which runs actually a UPF, and Kaloom also runs the software-defined fabric both here and in Montreal. And the Lenovo Open Cloud software that is actually used for managing the entire system from a hardware perspective. So that's also running in Montreal. Now let's take a quick look at what's happening in France. Well, in France, we have another independent network with radio, with the packet core running on a rack of servers with a fabric that's running by Cumulus. Again, we have a whole bunch of container network functions there with A10 NAT and firewall, Turnium SD-WAN gateway, open air interface software, that is the radio software as well as the packet core software. And of course, there we were able to get the 4G setup going in containers. So we have actually a 4G radio and a 4G phone that's set up over there. Now, a lot of people ask questions about, okay, so what was the full software stack? Can you actually show what that software stack looked like? Well, one of the interesting things we ran into was the number of community projects that were involved in this setup, as well as the amount of software that came from all of our partners and different vendors. So if you take a look at the left-hand side of that slide, all of those different community projects and products were involved in this particular setup. On a private cloud environment, both on OpenStack as well as on bare metal, we're running, of course, Linux software from Red Hat, and we're running the Kubernetes platform OpenShift from there, and then a whole bunch of container network functions or CNFs. In the public cloud environment, we are running, again, Linux, which is CentOS. We're running Kubernetes based on one of our partners called Ludza that actually provides provisioning of these Kubernetes environments called Kubematic. And then again, a number of CNF functions from various different partners. Of course, Intel is also providing a whole bunch of software, Altran, Ludza, so many partners to be involved in this. Now let's take a look at a quick animation of how things work first, and then we'll actually show you all the screens, and we'll actually show you hopefully a live call. Again, we've been having a number of challenges associated with this because we are trying to connect private cloud, public cloud, remote POP, all together over the internet with a whole bunch of tunnels, and I'm crossing my fingers, hopefully everything's gonna work. So let's take first. So what happens first is the two phones, the first phone here, that's on the stage here that you can see. I'm just gonna quickly walk you through. Here's your rack. That's the fabric that you see inside that's with blue lights, software-defined fabric. Here's the millimeter wave radio, the 5G radio, and that's the Faraday cage, and that's the phone inside there that's actually 5G. So first, when we power on the phone.
Why is the phone in a Faraday cage, Czar?
Oh, we couldn't radiate the frequency. This was millimeter wave. We had to actually show a live demo. We couldn't just hack it or show Wi-Fi or something else. So it was literally a custom-built Faraday cage. We sat in one of our colleagues' living room and built that over several couple of days. And I really, a lot of credit to my friend here, Pasi, for actually doing all the work that he did.
Yeah. So essentially, if we were radiating out 5G frequency, not being licensed mobile operators, we would be in violation of federal law.
Absolutely.
That's why it's in a Faraday cage.
Absolutely. So, so the two phones register. So that phone registers to the 5G core and the LTE core that's actually sitting in Montreal. So it's actually from here, going through that radio, going through that POP, and all the way into Montreal. So that's what you see by the yellow line. The other phone that's in France is registered to its local core right there. Now, obviously, since there are two different mobile networks here, and we don't have any roaming capability, we don't have any network-to-network connectivity like that, so we had to actually figure out a way to show you a live call across those two networks. So we actually decided to host an IMS capability in the public cloud. And what you see in the public cloud there is the IMS core right in the middle. And once these phones attach and have data connectivity, they connect to the IMS core and they actually exchange information, they do the IMS signaling and say, okay, now I can actually do an IMS call all the way across. So when that happens, now you can have actually a call all the way across. Obviously, we've been having some connectivity challenges, so we'll try to attempt a live call right here in front of you. We also have some other people on standby in Montreal and locally, so we'll show you whatever that's possible. So back, please. Let's now go to the screens.
Yep, so now we'll move over to the live demo and pull up stuff here live on the laptop.
Okay, so what you see here first is the dashboards. This is the OpenShift dashboard of the container Red Hat OpenShift container platform. And what you see here is the dashboard coming in from the Montreal POP. And you can see about 278 pods that are running in that Montreal POP. You can see there are 8 nodes there. There are 16 persistent volume claims. You can actually go into workloads and look at the pod details, and you'll see all these pods. Now, one interesting thing that I wanted to show you was the project that we are seeing here is the Altran 5G core project. Within the Altran 5G core project, these are all the different containers that are running as part of the Altran 5G core in the Montreal POP. We also happen to have in the Montreal POP a LTE core. So I'll just show you that as well. So Altran EPC. And you can see that there are a whole bunch of pods that are running as part of the Altran EPC in the Montreal POP. Now, what I'm going to do is also just show you very quickly this setup here, the 5G POP here, and the number of containers that are running here, about 215 containers or 215 pods on this setup. And you can also see different workloads here. This is default. Let me just go check here you go. This is the A10 setup. And I can scroll through any of those different projects to show you the different pods that are running there. So this is all live. Now, Kubernetes also provides the a monitoring capability as part of open source. We can actually go take a look at the cluster here, and we can actually take a look at the different workloads that are running. And this is all live from the different pods. But what's interesting and important is to actually get all of the different stats. And in OPNFV, Heather, you remember working through the Barometer project with a number of our partners. And we originally started that for OpenStack. Now we're applying the same project, same monitoring capabilities, common setup across private cloud, public cloud, and the POP here. And you can see the stats here right on the screen. Now I can choose any node. Interestingly, I only have one monitoring setup that also is looking at the Montreal POP and the local nodes. So the nodes that you see here right on top, 1, 2, 3, 4, 5, are from Montreal. And you can see these stats change. And the nodes that I'll show you locally is this one right here. So when I say worker 1, that is this node right here. Worker 0, it's in that particular 5G POP setup. And when I move to VCO worker, that's part of the Montreal setup. So you can actually see a whole lot of statistics around memory usage, network utilization, network traffic, memory distribution, loads, disk space, and on and on and on. So that's interesting. Now what I'm going to do is quickly show you first on this phone If they can zoom in onto the phone, please. I want to go back. Right here, you can see right on top something that says 5G UWB. It doesn't say LTE, it doesn't say 4G, it doesn't say Wi-Fi is on, it says 5G UWB. That stands for 5G ultra-wide broadband. So that's to show that that phone in that cage is actually attached to the 5G network. Now what we're going to try to do is attempt to make let's get one of our friends. Before we go to the call, let's go to we have a Twitter feed on the phone. What I want all of you to do, and this is probably one of those first keynotes where everybody says, shut off your phone. I'm going to say, pull out your phone, tweet with a hashtag called 5G Cloud Native. And hopefully by the end of this, I would be able to show you your tweets live on that particular 5G phone. So if you can, please tweet 5G Cloud Native hashtag. And let's now go back, while that tweet is happening, let's now go back and try to attempt to make a call. So can we get the remote team to call in, please? Okay, we have someone calling in. Let's accept. Call in, okay.
Are we dialing?
Yeah, we're dialing.
All right, cross your fingers, everyone. We are up here without a net doing a 5G call over a prototype cloud-native network.
All right, there you go. There's a call that came in. Let me just accept that call. I got the call accepted. Let's start the video feed. Yay. So that video you can see is coming from the Faraday cage. And we have, hello, how are you?
Hello, Hanan.
I hope you can hear us. And that's a live video feed over there.
All right, so everybody wave hi to Hanan, say hello to him.
Thank you so much.
Can you hear us now?
Excellent, we can hear something back. We can hear some audio back. All right. Okay, thank you so much, Hanan. That was wonderful.
All right, bye, Hanan. Adios.
All right, so we'll come back to the tweet in a
All
moment.
right, so just let's pause for a moment. It didn't look amazingly beautiful, but that was a live 5G call connecting across public and private clouds, connecting to a packet core in Montreal, an IMS core in the public cloud, and an LTE lab in France. So good job, Hanan.
Good job.
Yes, I have been so nervous thinking about that phone call for weeks and months now.
So what we have from one of our partners, NetScout, is actually an interesting monitoring application that does correlation. So what we showed you earlier was node monitoring capability, traffic monitoring capability. Now, this particular application from NetScout actually shows you a correlation. So it can actually show you things like SIP calls that are going through and attach to those different S1U interfaces on the mobile side to actually show you what's exactly going on. And you have various different dashboards here as well that can give you a pretty detailed information. And oh, by the way, all of this is completely live on all those three different setups that you saw earlier on. So
okay, let's go check our Twitter feed.
Yeah, let's go check our Twitter feed for a moment.
No network, no obsessively checking your Twitter. No network, no obsessively checking your Instagram feed. So
okay, so you see there was a new Twitter with you speaking right there. That just got updated. Here's another one that somebody just, I'm sorry. This is way too fast for me to scroll. Here's another tweet that just came in. So
it's working live. We did not make this up. We did not pretend with smoke and mirrors. This is not a canned demo. This was live. You can actually see your traffic going over the network. So,
absolutely.
So thank you, Azar.
Thank you.
Now let's go back to our slides.
Yeah. Lessons learned.
All right, so as we were building this, we did learn some lessons and we did find some gaps. Azar, do you want to talk about some of those technical gaps?
Sure. I mean, we've learned a lot of lessons. It was really a lot of hard work by a very large team, and I'm actually literally just representing them here. Some of the biggest lessons learned primarily for this community, for Kubernetes communities, networking. We have to solve a whole bunch of networking problems with Kubernetes still. We use Multus, we use secondary interfaces. The visibility of secondary interfaces isn't there. We didn't have custom resource controllers for those secondary interfaces. So it was a challenge trying to understand how things work, default routes, ETH0 versus secondary, and actually managing that whole capability. Because telecom infrastructure is all about networking. It's all about connecting those different parts together. It's all about connecting those different services together. That was one of the biggest challenges.
Okay.
The second biggest challenge was overall maturity, right? We don't have common descriptors for different network functions. We don't have common ways. Everybody has their own description file. And once you start to onboard them, everybody has a different expectation from the infrastructure. So the infrastructure really needs to evolve to be able to meet some of those capabilities. And we need some level of commonality. And perhaps the initiative that you have with GSMA in CNTT will help in terms of coming to a common agreement in how we actually build this type of infrastructure. Then, of course, there were a number of other challenges associated in the area of 5G space with radios, with frequencies, with getting the right kind of equipment, and hardening of that particular code for stability. But all those things, I'm sure we can talk about it offline. We don't need to spend more time here. But from a community perspective, I think it's a great opportunity for us to A, start in this environment, B, learn from these experiences, and C, build upon them to create some sort of an industry initiative. I'm sure you're going to talk about.
All right, cool.
Thank
Thanks,
you very
Azar. Let's give Azar another round of applause. All right, so Azar mentioned a couple of the challenges. So we really want to work in partnership with the cloud native community to solve some of the networking challenges. Also within the LF networking projects, we have a lot of initiatives going on around this, around cloud native reference architectures. That goes back to that partnership I mentioned with GSMA around CNTT. We recently kicked off an initiative around CNF compliance and validation testing. We've got things going on in ONAP to be able to support the provisioning of cloud-native network services. FIDO VPP, I know that we've heard a lot about that. That becomes very important for our high-performant networks, and they are doing some work on supporting the 5G user plane. And then we also are obviously working closely with the telecom user group here. If you want to get involved in any of these initiatives, I hope I might have inspired you to want to get involved in some of these things. Here are some links for places to get started and to learn more. We also have a developer event coming up in Prague in January. It is free to attend. We'd love to encourage any developers who want to work on this in the future. While you're here at the show, here's some more places you can learn more, whether that's on the booze, we've got some breakout sessions, and there is a suite at the Westin where you can sort of meet with some of the developers who put this together. And now, Azar and Fuchao, if you want to come back up, I want to take a moment to thank the partners who helped us do this. We had more than 15 companies participating and pulling this together. And most importantly, more than 80 community volunteer developers who did all of the hard work of pulling together these resources. And I'd like to stand up and have you stand up and be recognized. So. And what this really points out, honestly, is the power of open source, right? Bringing together people from 15 organizations, from 3 continents, multiple countries, multiple companies, multiple open source organization technologies. We were able to come together and build a prototype 5G network that is fully cloud native and actually demonstrate it. You can't do this in a silo. You can't do this on your own. This is the power of open source. So I encourage all of you for the rest of the time that you're here, get out of your silos, go talk to people who work on other projects, talk to people who work at other companies, talk to someone who's not from a place where you are from, and get to know people, build community. Because we are open source, we dream big, we build amazing stuff, and most importantly, we do it together.
All right. So normally I would say This is what's happening today. This is about lunch, and this is what we're doing this evening. But remember I mentioned it rained here last night? Well, we have a pretty important announcement before you go into the other items. We had a power outage at a substation, because San Diego just can't do rain. And we seem to have lost power in like 7 breakout rooms. And we don't know when the power is coming back on. So our great LF staff have created a plan. And as you can see in this slide, 5 of our sessions are moving to the Marriott Marquis. That's this away. And then we're going to have another session here, and then another session in Hall D. And I don't know the direction, so I'm just going to go like this. So Sched and our digital signage has now been updated. If you're using the Sched app, I guess you just go and update it to get the latest information. Yeah. So general attendee lunch will be served at 12:25 in Hall C, once again, in the West Terrace and 20 foyer. Tonight, join us at the all-attendee block party at the Gaslamp Quarter. That's this way, which is just across the street from the convention center. The party will go on, rain or shine. Badge is required, but please make sure to wear yours at all time. After the party, join us back here at 9 a.m. Actually, no. After the party, go home, get some sleep. Then join us back here at 9 a.m. for more keynotes tomorrow morning. There will now be a coffee break and a sponsor showcase. Sessions begin at 10:55. Thank you.
I wait to face, but in my heart I understand. I made my move, and it was all about you.
All right. So that was a tougher watch than yesterday. Give me 1 second. Let me get this stuff set up here. That's not what we wanted. All right. Let's do this one. Yep. We'll get rid of this music here, and we'll turn on some of this. So, that was a bit of a tougher watch today than it was yesterday, if I'm remembering everything. There were a lot of big announcements made yesterday. There were a lot of good speakers that came up. Today, the first hour was, woo, that was tough to get through. I'll say this. I want to say this in the nicest way that I can. Like I love being inclusive. I love indoctrinating new speakers, bringing new people up, infusing new blood into the technology sector. It's absolutely important that we do that, but there has to be some level of vetting, I guess, is what I would say, just to ensure that they're actually solid, energetic, entertaining speakers that actually have something to say. And I understand doing some of those sessions like they did as breakouts or as smaller meetup things in front of 10 to 20 people. When you put them on the grand stage at a keynote like this for what has become one of the major shows of the year, there's a certain level of expectation. And you got to keep that energy level up. That first hour was rough. And this is not a slight to any of the speakers. It's something that just, we've come to expect it over the years. There's power speaking courses. There's ways to be better at some of that stuff. I want the community around Kubernetes to be seen that way, right? I want it to be prolific and provocative and energetic and passion. And it takes away from some of that passion that I know is there, because you can see it in the work. You can see it in the projects. You can see it across the board. The amount of energy and effort and passion that has gone into the sheer amount of code and design and everything that's happened around it. But public speaking is no joke, guys. It's something that I wasn't good at initially, but it takes reps. It takes time. It's a muscle you have to exercise constantly. And if you don't, it's not going to go well, especially on a stage in front of thousands of people and potentially tens of thousands of people watching on a live stream around the world. So, yeah. Just, it's something that reach out to me on Twitter at DatacenterDude. I can make some recommendations for some power speaking coaches. I've taken thousands of dollars and many, many hours worth of power speaking courses over time. This is not something you just wake up one morning and start doing. The same way you don't just sit down and start writing code and, stable software one day out of the blue. It takes years and multiple repetitions. Creating solid presentations is something that takes years. Telling a story is something that takes years. And it felt a little amateur hour for the first hour of today's keynote. Yesterday felt more formulaic and like a keynote. Today felt a little, until we got to the 5G stuff with Azar and Heather. Man, that was a great way to close it out. But, yeah, lots of stuff going on. Hey, heads up, I hope you guys saw they are changing a bunch of stuff around because apparently there was a huge weather event, lots of rain. By lots of rain, I mean it probably drizzled in Southern California, which shuts everything down. It's much like ice and snow here in the Southeast. We empty all the bread and milk out of the grocery stores. Well, when it rains, when the road becomes wet, the traffic gets 20 times worse in Southern California. So they're having a bunch of problems. Make sure you check. There's a screenshot that I'm going to tweet here in just a second that of the room changes. Apparently, there's a bunch of rooms that don't have power. So yeah, that's it, guys. We'll be back tomorrow. Make sure you hit that follow heart up above so you get notified when we go live again. We'll be back tomorrow, 9 a.m. Pacific, noon Eastern, for day 3, the last day of KubeCon 2019 from San Diego. And we'll be doing some reviews of this content on Friday on the main stream right here on the channel as well. We do, starting at noon Eastern every Friday, we do a big stream. So make sure you subscribe to the channel here, and we'll be back. We will see you guys tomorrow. Until then, take care, everybody.